Hi, I'm Shazila. I want to explain our visual experiment of static friction on an inclined plane. This, the topic related to this experiment at chapter 4, Power and Motion. But in chapter 4, we use topic 4.2 newtons, second law and 4.6 friction. The task have two, that is task 1. We need to determine the critical value of the static friction force before the block move, and task 2, we need to determine the angle before the block move. Procedure, the first step is complete. Task 1, use the link provided to assist use in conducting this experiment and set parameter.
For task 1 is to determine the critical value of coefficient of static friction before the block is moving. So based on the table, the coefficient of static friction 1.0 until 0.6, the block is not moving. But 0.5 until 0.0, the block is moving. The last value of coefficient of static friction when the block is still static is 0.578. And the first value of coefficient of static friction when the block is moving is 0.577.
Hi, I'm second member. This is the experiment. We're just going to same website and we're going to keep in the same value too. So here we are. Starting from initial velocity is 0, gravity 9.8, mass 10, coefficients of static friction 0.42, coefficients of kinetic friction 0, and angle 0 degrees. Okay, let's see the table 2. If we put 0 degrees, it means not moving. So we have x here. We do all the angles have. And the angles that is moving put yes. It means we need to this right here. Then in this table, the finest angle we get 22.7 degrees for example 2. We do the case when it starts moving 22.8 degrees, so we key in the numbers here. We need to prove it, 0 or not. Let's see the calculations for example 1. 10 bracket 9.8 sin 22.7 minus 0.42 bracket 10 bracket 9.8 cos 22.7 equation negative 0.1529. Then let's see the calculations for example 2. 10 bracket 9.8 sin 22.8 minus 0.42 bracket 10 bracket 9.8 cos 22.8 equation 0.0326. So the numbers we get it's 0.
Okay, so for discussion in task one, the question is, if the mass of the object reduces, will we have a different coefficient? So the formula we're given mg sine theta minus mu n, which to prove our finding, and we get the solution of 0. So when the mass of object reduce, coefficient friction not change because the block will still be moving. And for task 2, the question is, if we change the material of block and plane from wood to steel, do we expect a higher angle before the block start moving? So using the formula and a given information, so we get on wood we got the solution for minus 0.15, while on steel we got minus 29.08, which we expect a higher angle because the block will with steel needs a higher force before it starts moving, so the static friction for steel is greater than for wood. Right.
Hi, I'm the last member. So, for the conclusion, referring to task 1, coefficient of static friction is a factor moving the block. for the case above, the critical value coefficient of static friction when the block is moving is 0.577. Mean the coefficient needed for the block move is 0.577. For the task 2, angle is a factor to move the block. For the case above, the critical value angle of the plane when the block is moving is 22.8 degree. Means we need 22.8 degrees angle to move the block. Bye!